Hey everyone, welcome to my channel. So today we are going to do weekly challenge. First question: apply operation to an array. So in this question, let us first read this question, then about constraint, and then we will be going bit about the intuition for the same. So here you are given a zero index array num of size n non-negative consisting of non-negative integer, and you need to apply n minus 1 operation to this array where in the ith operation, see, where in the ith operation basically at a zero index. So the thing would be that you will apply the following of the on the ith element of nums, and the operation would be like if nums of I equals to nums of I minus 1, then multiply nums of I by 2 and set the nums of I plus 1 equal to 0. Otherwise, you skip this operation. So basically, when present and the next element, both of them are equal, then you are required to just multiply the present by 2 and set the other number, means just the next number which is there as 0. So this is the thing. And the next thing which you are required to do is that after performing all operations, shift all zeros to the end of the array. For example, the array of 1, 0, 2, this after shifting all zeros to the end, it will become something like this. So basically this question is divided into two parts. First thing is that we are required to perform this particular operation, and then after that we are required to perform this operation, that is shifting all the zeros to the end. So without affecting the relative positions. You can clearly see that 1 is at the starting, then after that 2 comes, so that's why here also 2 is there, and then at the last 1 is there, so after that 1 is there, and all the zeros are shifted to 0. So that's why this question becomes split into two parts, and that we are required to do in this question. Here in the first you can see, but regarding this operation, there are two things which is in doubt after reading this question also. First thing is, not two things, basically one thing is in doubt, that what we are required to check means this nums of I equals to nums of I plus 1. Is it about the answer means, see, when we will be going ahead with this operation, mm, take it for example only, when we are given with this thing, right, and this thing, that surely we will be skipping. And then when comes the part for these two things, then we are required to then we are required to check that both of them are equal or not. And as both of them are equal, right? So because of that we will be modifying 2 multiplied by 2 equal to 4, and this would be modified as 0. So now the new answer array would be 1, 4, 0, 1, comma 1 and then 0. Now here the doubt is basically that here, okay, this is done, then this would be skipped, and now comes this part, right? This 1, 1. It's alright, it would be also skipped, and then comes the part this. So again, this operation would be performed, and it will become 1, 4, 0, then 2 and 0 and then 0. Okay, which we performed on our final means final answer which we were getting, right? And the other scenario which I'm saying is that if by chance uh we were given with some input like this 1, 2, 2, 2, right, and 1, 1 and nothing. Okay. So then we perform these operations. Then we perform these operations, then it would be something like this 1, 4, 2, 2, 1, 1, right? And after performing the second operation, if we perform that second operation which is there, if we perform that operation on the original array only, then it would have been 2 to equal. But if we perform that particular 0 here, if we perform on this particular, right, then it won't be equal, right? So we will be skipping this thing, right? So for this confusion, they have mentioned this particular note that the operations are applied sequentially, not all at once. So this simply refers to that we are required to check for our answer which is B. means after every step, whatever answer we will be getting, so then we are required to check for that particular array rather than checking the original one. So this is the thing which we are required to do in our solution. So now here the thing would be that let's first check about the constraint, then I'll go ahead. So here the constraints are pretty much low, that is 10 raised to power 3 only, and the size of and the each element of that num is also 1000, right? So because of this only we go ahead with n square solution, n log n solution, both of them would be working. But the thing is that here, as per the operations which are there, we can easily go ahead with n solution as well. So how that solution would be? First thing is that the way we are saying that we are required to perform the operation, right? So we will be performing this operation, and this operation we will be performing at our answer which we are basically storing, means sequentially as we are required to store, means after every operation we will be performing this operation on that particular. This will be our first thing. And the second thing would be after getting our answer, right? Means answer vector which would be there. After getting that, then we will be doing the question of shifting our question of moving zeros. And because of that only, we will be shifting all zeros towards the end. So this is the thing which we are required to do here. Now let us go ahead with the coding part for the same. Okay. So the first thing which we are required to do is, so first for end I equals to 0, I less than nums dot size I plus plus. So we are basically traversing our nums which is there. Now comes the part for vector in answer, and at the starting only let us make it equals to nums. So all the elements will come in that answer only. Now here we will be first checking that if here also we are required to mark it minus 1 basically. So here we will be checking if answer of I equals to answer of I plus 1. This is a fact, and then uh, if both of them are equal, then we will be performing our operation which is there. Then answer of I equals to answer of I into 2, uh, this thing, and then answer of I plus 1 equals to 0. So both of these things we will be moving ahead. So this is for our means conversion things, means, right? And now comes the part for moving all of them to the all the zeros which are there at the end. So now for moving all of the zeros at the end, what we are required to do here is that we will be directly means the way we did that particular question, like that manner only we will be doing here. Now the thing is that we will be going ahead with storing that whatever last occurring zero which was last non-zero element which was there, that we will be picking up, uh, so that there is no confusion, that's why we will be directly writing like this. So this we will be going ahead initializing with 0, and then we require one more which will be keeping track of our current element. This is the thing, and these two are done. Now this would be that one which will be keeping track of each and every element, right? So that we will be going ahead with the same. And now comes the part that we will be checking that if the answer which is there, if our answer of current is okay is not equals to 0, that we will be checking. Okay, if it is a non-zero thing, means present element is non-zero, then we will be going ahead and okay, if it is a non-zero, then we will be directly swapping at this particular index which is there. with our current. And then at the end, we are required to return our answer. So this was for sample test case. Just go it for others. So it got accepted. Now, now comes the part for the time complexity and space complexity. So your time complexity order of n. Here also time complexity order of n in the worst case scenario. So yeah, and about the space complexity, that order of 1, because this is required one, so that's why we are not taking the space complexity into consideration. So that's why either time complexity is order of n and space complexity is order of 1. So this was all for this particular video. And yeah, one more thing. Um, Newton School has started with the coding contest, about which you can figure out with the link in the description below, and all the information you can find in that description. And after clicking that link, then heading over to that particular web page. So the thing is that as you're already doing with these Leetcode daily challenges, Leetcode weekly, bi-weekly contest, and doing one more contest will add up to much more practice, and that would be good enough to go ahead with the same. So, and moreover, when you are in the top performer, then surely you would be getting some exciting prizes for the same. So you can head over towards that link in the description. So yeah, this was all for this particular video. Thank you.